All right, so here we have a value of an annuity, and this is going to be interest compounded in times per year. So it could be, twice a year, 4 times a year, every month. So it'll be 12 times a year. So again, we're going to deposit some value P at the end of each compounding period, whatever the period is, for an annuity that pays an interest rate, again, an R of R, and again, decimal form, compounded in times per year. And our future value A after T years is going to be given by this equation. So again, future value, P is going to be how much deposit at the end of each compounding period. R is the rate in decimal form here and here. N is the number of times we're compounding it per year or per year. So it goes in those three places, and T is going to be the number of years. And then we have to plug that whole thing into our calculator all in one time. So with that said, let's say at age 30, to save for retirement, we're going to decide to directly deposit $100 at the end of each month into an IRA that earns the equivalent of 9.5% compounded monthly. So if it's monthly, guess what that means? That means N is equal to 12. Okay. Now, how much will you have from the IRA when you retire at 65? Well, 65 minus 30. So that means T is equal to what? 35 years. Okay, so we've got two things so far, and we got 9.5%, so that's going to be a rate of 0.095, again, because we have to put it in decimal form. So that means now, for one, we just have to plug all of that into our future value formula. So we're going to plug in $100 at the end of each period, and then we'll have 1 plus, oops, where we got here? Erase. We have 1 plus 0.095 over 12 for 12 compounding periods. And then we're going to take 12 times the number of years, which was 35. And then we'll have minus 1 all over. And again, it's going to be our 0.095 over 12. And then that should give us then what our future value is going to be. So let's type all that into our calculator. All right, so we had 100 times, then we had 1 plus 0.095 divided by 12, and then that was raised to the power, and we had 12 times 35. Now we have to remember to arrow down, and then we had minus 1, and then parenthesis, and then that then was divided by, and then parenthesis 0.095 divided by 12. And if we typed all that in right, this is going to be our value. So $333,946.30. So let's go back over here. And so that goes and says, okay, well, that's going to give us $333,946.30. Now it says round to the nearest whole dollar. Well, now this time rounding down is the only way that makes sense. And so 333,946. That's what the future value is going to be. Now, same thing happens here. What are the earnings from this investment, or how much interest did you make? Well, first of all, how much did you pay? Well, we paid $100 each month. So there's going to be 12 months per year, and we did it for 35 years. And so that's going to be what? Multiply all that out. We're going to get 100 times 12 times 35. So we're going to get $42,000 is all we actually invested here. So that's going to give us 42,000 deposited. Okay. Now, so what's interest? That's going to be 333,946. And then we're going to subtract off the 42,000. And that's going to be 6. That's going to be 4. That's going to be a 9. That's going to be a 1. That's going to be a 9. That's going to be a 2. And so this is going to be how much interest we made on just depositing that $42,000 over those 35 years. So quite a bit of interest that we're actually gaining here. All right. So that kind of shows you that really is you want to save money. So annuities can be categorized by when payments are made. The formula used to solve the previous problem described ordinary annuities, where payments are made at the end of each period. The formula assumes the same number of yearly payments and the yearly compounding periods. Now, an annuity plan in which payments are made at the beginning of each period is called an annuity due. Now, this formula for the value of this type of annuity is slightly different than the one used in the previous problem. And in practice, we determine the future value of an annuity using calculators or software that have built-in functions for this purpose. And so what we're going to do is we're going to do the same calculation with our calculator and also using Excel. So same problem we just did. We already know the answer. So now we're going to see if we can get the right answer. So let's go to our calculator. Let's clear everything out. And to do this problem, we're going to go over to apps. We're going to be doing financial stuff. So we'll click 1. And we're going to do this solver because we're going to solve for a specific thing. Now, for that problem, it said we were going to do this for 35 years and it's going to be monthly. So that's going to give us 12 times 35. And I'm just going to have the calculator calculate how many times that is. So that's 420 times. Interest, they said, was 9.5%. This time we actually calculate, when we put it in here, we put 9.5 because it's with a percent sign, and that's how it's going to stay here. It'll convert to the percent for you. Then we're going to have a payment. And so payments are going to be given out. And so in this case, we're actually going to say it's going to be a minus $100. And that way, when we get it done, our future value is going to be positive. So that's going to help us get a positive future value, is because we're paying that much out. Future value is what we're going to calculate, so we're not going to do anything with that yet. And the number of payments per year or whatever, we're doing it 12 times because we're doing monthly. And so it's going to be 12. And so when you type it in one, it automatically puts it in both. So that's kind of nice. We're doing it at the end of the period. So that's what we're going to choose here instead of the beginning. And so now we're looking for what is the future value. So to calculate this, we're going to hit alpha and we're going to hit enter. And it gives us our value directly. So all that big formula we had, guess what? It's done all in the calculator and gives us the same value. So 333,946.30, same number we had before. So that works very well for here. Okay, so again, with TI-84, we get 333, then 946.30, or again, 333,946. All right, so then with the Excel, what we're going to do is I've started building a spreadsheet with this. And so we want the value of the annuity. Okay, so with the value of the annuity, what are we going to do? Well, how much are we going to deposit? And again, we need to say we're going to deposit a negative $100. The rate, we're going to again say 9.5. We're doing the number of deposits per year. Well, we're doing it monthly, so it's 12. And we're doing 35 years. Okay. And it gives us again the direct thing. And how did it do that? Well, what we had to do is we had to use a future value formula. And so the future value formula, let's go through how that works. It's in your book, but we can show you how it works here. It's going to be equal to, and how you do this is you say equals future value. And so you double click on that. And then you want the rate. All right, well, the rate is not going to be 9.5. It's going to be this number divided by, and we're going to have to divide it by, and we're going to have to divide it by monthly, so divided by 12 times 100, okay? And then parenthesis. Now, NPR, and the number times per, okay? Well, that's going to be the number of times we're doing it. So it's going to be this number times, and then we hit times this number. So that's going to be our 420, or if we just multiply it out, we can use this for anything. And so that would be that. And so then our deposit is this number. And so that's going to be how much payment we have. Now, present value, we are not going to worry about, and the type we're not going to worry about. And so then we hit parenthesis, and hopefully we get same thing. And so that's how we're going to use our future value. So again, if we had gone ahead and figured out the calculation for the actual annual rate and put in the percent and done all the work here where we took 9.5 divided by the 12 times 100 and put that in here, then we wouldn't have to do the calculation within our function here. And the B4 times the B5, which is just the number of times we did it, we could have calculated that itself and instead of having to put it here, and that would have been fine. And then B2, again, because we want a positive number out for the value of the annuity, that's going to be a negative 100 because we're paying that to the bank to put it into that. And so then that's how much is going to come back to us in the future. Okay. So again, same number both ways we get. And so that's going to be the same thing here. We're going to have, uh, that's going to also be for Excel. All right, so let's stop there and we'll come back for more.